All right, so the goals for this week is we're going to explain the meaning of solutions. So I'm highlighting the word solutions because that is going to be a vocabulary word that y'all probably are already familiar with, but I'm going to be using it more. And so hopefully that will become easier for you to understand, okay? Next, we're going to be finding solutions to equations. And we're going to be reasoning about the relationships in context. So not only are we going to be finding them, but we're going to see if it makes sense for that situation. And then finally, we're going to be interpreting those, like not only does it make sense, but what exactly does that mean? So if we get that x equals some number, okay, what is it saying that number equals? Okay, what does it mean in this particular problem? Okay, so let's go ahead and get started right into this lesson, 4.1, what is a solution? Okay, so there it is once again. Okay, so let's break down this little paragraph at the beginning together. Okay, so underline and highlight where I do. So it says we're talking about a granola bite and it contains 27 total calories. Okay. Why is my pen? Okay, there we go. Most of the calories come from C, which C stands for grams of carbohydrates. The rest come from other ingredients. Right here when it says the rest, what is it talking about? The rest of what? It says most of the calories come from carbs. The rest come from other ingredients. The rest of what?
The rest of the calories?
The calories. Good. All right, and then finally it says 1 gram of carbs contains 4 calories. Okay, so they gave us all this information, and just like what we've been doing in the last 3 lessons, they went ahead and came up with an equation to represent and model that relationship. Okay, so it's right here. They said 4C plus 5 equals 27 represents this relationship. Okay, so let's break that down and see if we know what everything's talking about, because this equation came from all of this information up here. I'm sorry, my computer is lagging. All this information up here. Okay, so when it talks about that 4C, okay, what did the C stand for?
Calories.
Not calories.
Grams of carbohydrate.
Grams of carbohydrates. And then the 4 represented what?
Uh, 1 gram of carbohydrates contains 4 calories.
Okay, good. So for each gram of carbs, it's 4 calories. So that's what that 4C represents. Okay, and then we have this 27, which represented what?
How many calories the granola bar or bite contains?
Yes, so the total amount of calories. Good. Okay, so then it brings us to this first question. It says, what could the 5 represent in this situation? Okay, so let's put it into our own words. What's the only thing that we haven't talked about in this paragraph up here? What could that 5 represent?
How many?
Do what?
How many granola bites there are?
No, not necessarily. This is all from, it's just from one granola bite.
I said the other ingredients.
The other ingredients, good. It's this part right here that we highlighted in blue. So it represents the calories from the other ingredients. All right, give me a thumbs up if we understand where this equation came from in our situation. Okay, so we can see that this is not just a bunch of random numbers and letters thrown together. It's actually modeling a real world situation, just like what we've talked about. Okay, which brings us to question number 2. It says, Priya said that neither 8 nor 3 could be a solution to the equation. Explain why she is correct. Okay, so we already know 8 and 3 are not going to be a solution. Okay, but when we use the word solution, what are we talking about? What does it mean that they're not solutions?
It wouldn't make the equation equal.
They wouldn't make the equation equal. Good. Okay, so let's come over here and put 8 and 3 won't make the equation equal. Good. Okay, but now it says explain why she is correct. So this is what she just said, because she said they are not a solution. She's saying that they won't make the equation equal. How can we prove that or explain it? How can we prove that 8 and 3 won't make the equation equal?
Like plugging it in.
We can plug it in, okay? So we're going to start, basically she's saying that C equals 8 and C equals 3. Okay, so let's plug that into our equation. So we have 4C plus 5 equals 27. All right, what am I going to do with this C right here? What did Hayden just tell me?
You're gonna plug it in.
Plug it in, okay? So everywhere I see a C, I'm going to change it to an
8.
8. So I have 4 times what?
8.
8 plus 5 equals 27. Okay, what's 4 times 8?
32.
Good. Is 32, what's 32 plus 5?
37.
All right, does 37 equal 27?
No.
Nope, it does not. So can we see that it did not make the equation equal? Y'all see that that's not a solution?
Yep.
Okay, so no, 8 is not a solution. All right, let's try with C. So we have 4C plus 5 equals 27. What are we going to do with this C right here?
Plug it in.
Plug it in. Okay, sorry, my mouse is being real slow. So we have 4 times 3 plus 5 equals 27. All right, what's 4 times 3?
12.
12.
12 plus 5 equals 27. What's 12 plus 5?
17.
17. Does 17 equal 27?
No.
No, it does not. So that would not be true. So once again, it is not a solution. Okay, so right here on number 3, it says find the solution. So how do we find a solution to a problem? What is it wanting to know? If it's asking us to find the solution.
What would make it equal?
Okay, good. What would make the equation equal, or what would make the equation true? Good. All right, so I'm starting out with my equation. I have, let me mark off this so it doesn't all bleed together. All right, so we have, let me zoom in a little bit so that I can have more room. Can y'all still see?
Yeah.
All right, so we have 4C plus 5 equals 27. Oh my gosh. 27. Okay, how, and we've talked about this before this year, how am I going to find out what C equals?
Get it by itself.
We have to get it all by itself. All right, so I'm trying to get this C all by itself, so I have to get rid of this 5, and I have to get rid of this 4. What am I going to start with?
5.
I'm going to start with a 5 because it's my term that's farthest away. So how do I get rid of a plus 5?
Minus 5.
5.
Minus 5. If I do it to one side,
Gotta do it the other.
got to do it to the other side, okay? All right, what's 5 minus 5?
0.
0. All right, and then I have 4C that comes down. And that equals, what's 27 minus 5?
22.
All right, 1 second, let me clean this up. Okay, now I have 4 times C. How am I going to get that C by itself?
Divide
I'm going to divide it by
4.
4. Sorry, my mouse is freezing up. All right, if I do it to one side,
Gotta do it to the other.
got to do it to the other. My 4's cancel. And I'm left with C equals 5.5. All right, so what are we talking about when we're talking about C?
Wait. The grams. I don't know.
We're talking about the grams of carbs, right?
Yeah.
So how many grams of carbs are in this particular granola bar?
5.5.
Good, 5.5 grams of carbs. Good. All right, give me a thumbs up if we've got all that written down. Awesome. Thumbs up. Thumbs up. Awesome. Okay. So 4.2 weekend earnings. Okay, so this particular problem is also going to combine what we've done in previous lessons, okay? Not only are we going to have to create the equation, we're going to have to find the solution. Okay, so bear with me. We got it. I promise we'll get through it. So it says, Jada has time on the weekends to earn some money. A local bookstore is looking for someone to help sort books and will pay $12.20 per hour. Underline or highlight $12.20 per hour. To get to and from the bookstore on a workday, however, Jada would have to spend $7.15 on bus fare. All right. And I want you to really look at, oh snap, spend $7.15 on bus fare. All right, and then it says write an equation that represents Jada's take-home earnings. And what variable are we going to use to represent take-home earnings? What did it tell us to use?
E.
E. All right. If she works at the bookstore for 8 hours, what are we going to use to represent hours?
H.
H. Okay. So let's write an equation. So I always like to start out with, because I understand that writing equations is not the easiest skill to grasp. Okay, so what I like to do is I like to think about it as if it were me in this situation. Okay, so let's put ourselves in this situation. So we just got a job and we know we're going to be making $12.20 per hour. Right?
Right.
Okay, so what is a reasonable amount of hours that we could work in a day?
7.
7 hours. Okay.
Seven.
All right, I heard 7 first, but yes, 8 hours will work as well. So if we were making $12.20 an hour, and we worked for 7 hours, how would we mathematically figure out how much money we made?
Subtract it.
Multiply.
We'd multiply it.
Okay.
So that's how much we make in 1 hour, but we worked for 7 hours. Okay? Oh, snap. Sorry. Okay, so that's how much money that are going to make in 1 day. Okay, but look, we have to think about this. How are we getting to work?
The bus.
We're getting to the bus, and we have to spend $7.15 of that money we earned. So then what do I have to do?
Subtract it.
I have to subtract it. Okay. So I have to subtract $7.15. Okay, now out of these 3 quantities, which was the one that we weren't given in our original little paragraph?
The hours that she
The
worked.
hours, okay? So which one of these did we say were hours?
7.
The 7.
So what are we going to replace that with?
H.
H. All right, so if we do 1220 times however many hours we worked, we subtract off the bus fare, what's that going to tell us?
The take-home earnings.
The take-home earnings. Okay, so let's look at that just one more time before we move on. If we know we make $12.20 an hour, we're going to multiply that amount by however many hours we work. But if we have to spend money on our bus fare, we're going to have to take that amount off of the total that we make. And that's going to be how much we get to take home. All right, thumbs up if that makes sense. Awesome. Now, we're going to expand on this equation a little bit further. In number 2, it says one day, Jada takes home $90.45. All right, so if she's taking home $90.45, what variable does that equal?
E.
E. Oops. E equals $90.45. All right, and then once again, it says she worked for H hours. So do we know how many hours she worked?
No.
Nope. And she paid the bus fare. It wants us to write an equation to represent this situation. So everything is literally the same. What's the only thing we know now that we didn't know before?
E.
E. Okay, so did she work the same, did she get paid the same amount?
Yeah.
Yeah, it doesn't say she got paid a different amount. It's still at the bookstore. Okay, so we're going to write $12.20. Do we know how many hours she worked?
No.
No.
What are we going to do? Do we just leave it as H?
Yeah.
Yeah, so times H. Did she still pay the bus fare?
Yeah.
Yep, so what are we going to do with it?
Subtract.
Subtract it. All right. And then what are we going to do for E?
Put $90.45.
Put $90.45. Good. Oh no, why is that doing that? Why does it have to be? Okay. Don't know. All right, moving on. It says, so now we have an equation where we're just missing one variable. Let's see if this works a little better. All right, it says, is 4 a solution to the last equation? What about 7? How are we going to determine if those are solutions to this equation?
Plug it in.
Plug them in.
We're going to plug them in, and I'm going to teach y'all a new word real quick because what you're saying is not wrong, but you will never see that word in math. They're going to say this word instead. Okay, when you're saying plug it in, the word you will see is substitute. All right, so that means those things mean the same thing, okay? I just want to say that because in a couple lessons we're going to get into substitution. Okay, so what this is saying, let's split up our paper so we can stay organized. I know there's not a lot of room left, I'm sorry. This is saying that H equals 4 and H equals 7. All right, and we said we're going to determine if it's a solution by doing what?
Substituting.
Substituting, good. Okay, so let's write our equation. All right, so we have 12, 20, H, or I'm sorry. Instead of H, what are we going to plug in? 4. Minus 7.15 equals 90.45. All right. I know I didn't tell y'all to get a calculator, so I'm just going to do it on my phone. So we have 1220 times 4, and that's 4880 minus 715 equals 90.45. So we're going to subtract 715, and that's 41.65. All right, so this is what we're left with. So is 4 a solution to this equation?
No.
No. Because if she worked 4 hours, she would have made $41.65. Okay, so that is not a solution. All right, let's try the other one. We have 1220. What are we going to do with our H?
Put a
Substitute
7.
7.
We're going to substitute our 7. Okay, so we have $12.20 times 7. That's $85.40. Minus 715 equals 90.45. All right, so then we have to do this part. 85.40 minus 715 is 78.25. Does 78.25 equal $90.45?
No.
No, so is it a solution?
No.
No, 7 is not a solution. Okay, so give me a thumbs up if you have that copied down. We're ready to move on. Awesome. Okay, so down here on the next, or on your next page, it says, be prepared to explain how you know one or both of them are solutions. Well, we discovered that both of them are not solutions, right?
Right.
Correct. All right, so it says, if not, be prepared to explain why they are not solutions, and then it says, then find the solution. Okay, so how did we prove that they were not solutions?
Substituting the numbers in.
We substituted. Good. All right, so how can we prove that how can we find the actual solution? How did we do it earlier with the carbs?
We got the variable by itself.
We got the variable by itself. I'm gonna get the variable by itself. All right, so let's write down this equation. We have 1220H minus 715 equals 9045. Okay, what variable are we trying to get by itself?
H.
We're trying to get H by itself. All right? So someone tell me what's going to be my first step in getting that H by itself? Somehow we have to get rid of a minus 7.15 and we have to get rid of a times 12, $12.20. So I always start with the term that is
Furthest.
furthest away. So how do I get rid of a minus 715? I'm going to add 715. Good. Okay, if I do that to one side,
You gotta do it to the other.
got to do it to the other side. What's going to happen to my 715s over here?
We're
Cancel
gonna
out.
cancel out.
I'm going to cancel out, and I have 1220H equals 95.05. I have 9760. Oh. Okay, next step. I have 1220 times H. How am I going to get that H by itself?
Divide.
I'm going to divide it. If I do it to one side,
You gotta do it to the other.
got to do it to the other side. My 1220s cancel, and H equals 8. All right, so it says in number 4, in this situation, what does the solution to the equation tell us? So this is my solution. What does it mean that H equals 8? What does that mean in this situation?
The hours.
The hours? Okay, so let's put it into a nice sentence to explain it. Who are we talking about in this situation?
Jada.
Jada. All right. What does it mean, 8 hours?
She worked 8 hours.
We worked 8 hours. Okay, so going back up to our goal, we're thinking about our goal. We're finding the solutions, and we're talking about what it means in context. We're interpreting the solutions to the equations. Okay, so it doesn't help us any if we get through this long equation and we get h equals 8 and we don't know what that means. That's why it's important to know what our variables are talking about. Okay, so that we know that h equals hours, so that means that Jada worked 8 hours. Yes, sir. Hayden?
So I was able to find it a different way.
Okay,
Yeah.
how'd you do it?
It was okay. So like I added 90.45 and 715 like as my first step, and then got 97.6 and just divided that by 12 to 20. Is that what
Yeah.
you did?
That's what we did.
Okay.
I just showed all the steps for my equation.
Okay.
What, did I do something different?
No, I don't think so. I
Okay.
think I just might have skipped something.
Oh. All right. Let's see what the next part is. All right, so we're gonna do this part and then we'll take a break. All right, it says 1 gram of protein contains 4 calories. 1 gram of fat contains 9 calories. A snack has 60 calories, where P stands for
Gram.
grams of protein and F is grams of fat. All right, so once again, they've taken this and they've come up with a nice equation for us. Anytime they give you an equation, I would put a box around it, highlight it, do something with it because it's important. All right, so that represents this situation. It says determine if each pair of values could be the number of grams of protein in the snack. Be prepared to explain your reasoning. So what is it asking us here? What is it asking us if what these values are? What's that word we've been talking about?
So
Solutions. They're asking us if they're solutions. How are we going to determine if these values are solutions?
you're gonna substitute them in.
We're going to substitute them in. Good. Okay, so I'll do the first one with you, and then I'll let you do B and C on your own. Okay, so it's saying that there's 5 grams of protein. So what does that mean? That P equals what?
5.
5. All right, and then it says there's 2 grams of fat. So what does that tell us?
That F equals 2.
F equals 2. Okay, so we have our variables. We have an equation. Sorry, I don't know what the deal is with my mouse today. All right, so right here I have 4, and what am I gonna plug in for P?
5.
And I have 9, and what am I gonna plug in for F?
2.
And if all of this works out, what should it all equal?
60.
60, okay? So let's see. What is 4 times 5?
20.
20. Plus, what's 9 times 2?
18.
18. All right, is 20 plus 18 60?
No.
No. So are these solutions to this equation?
No.
Not a solution. Okay, now I want y'all to attempt it on your own. For some reason, my Zoom is not letting me do chats. So just send it on the Go Guardian chat. You may have to go to like Google Chrome to send it. So once you get B and C, just send it in the Go Guardian chat whether you got solution or no solution. Okay, I'm going to give y'all about 3 or 4 minutes to do this on your own. Ready? Go. Next, we have 8 grams of protein and 4 grams of fat. Is that a solution?
No.
No, that is not a solution. Good. Oh my gosh. Why is this the way that it is? Just gonna erase it. That's not working. Oh my gosh. Why? Okay, 1 second. All right, so for number 2, it says now there are 6 grams of fat in the snack. What does it want to know?
How many grams of protein there are?
Okay, good. All right, so if there's 6 grams of fat, what variable is fat?
H.
Not H.
Oh,
F.
I'm not H. I mean F. My bad.
So F equals what?
9.
6, right?
No.
Okay, what about, do we know what protein equals?
No.
No, so what are we going to use in place of protein?
P.
P. Okay, so let's go back to our equation that they gave us up here earlier. Sorry, it deleted everything for some reason, but y'all should all still have it. So we have 4P plus 9F equals 60. All right, so let's rewrite it with what we know. We know this is 4. Do we know what P equals?
No.
Nope, so that stays P, right?
Yep.
Okay, that's plus, that's 9. Do we know what F equals?
6.
We know it equals 6, so we're going to substitute the 6. And that all equals what?
6.
60. All right, give me a thumbs up if that part right there makes sense, what we just did. Okay, awesome. So let's simplify this part real quick before we can do anything else. So this stays 4P. Oops, didn't mean to make that green. 4P. All right, what's 9 times 6?
54.
56.
54. All right, so I'm just going to draw an arrow up here to show y'all that I'm going to continue working it over here. All right, so let me rewrite it. Okay, what are we trying to find again?
What P equals?
P.
What P equals, okay? So we're solving for P. All right, how am I going to start by solving for P? What am I gonna do?
You're gonna subtract 54 from 54.
I'm gonna subtract 54 from both sides. Oops. All right, what happens to my 54s?
They cancel.
All right, I'm left with 4P equals, what's 60 minus 54? 6. All right, so now I have 4 times P. What am I gonna do?
Divide by
Gonna
4.
divide.
Divide by 4. Those cancel. And I'm left with P equals 1.5. All right, what does P stand for again?
P
Protein.
stands for
Grams of
Protein.
All right, so how many grams of protein do we have?
1.5.
1.5.
Okay, last question and then we're done, okay? It says, in this situation, what does a solution to the equation that they gave us tell us? What would a solution tell us?
How many grams of protein and how many grams of fat?
Okay, how many grams of protein and how many grams of fat? So let me start typing so that y'all can see it a little easier. How many grams of protein and fat? Okay, but there's a little bit more to it. What does it have to equal? Okay, would combine to equal 60 calories. All right, give me a thumbs up if you've got that written down. Tyler, you got it? Awesome. Sorry, I'm just scrolling down my list. Not calling anyone out. Kaden, you got that? Got it written down? Haley, you good? Awesome. Okay, so let's look at lesson summary. What page is the lesson summary on?
159.
159. It's like half a page. Right.
Not bad.
Tony.
All right, so hopefully a lot of this was just a review because it was a lot of solving for variables and a lot of like substitution, which y'all have done previously. But we're gonna see, but they connected it back to creating our own equations and then making sense of what those solutions meant in the situation. So it's going just a little deeper with it. So it says an equation that contains only one known quantity or one quantity that can vary is called an equation in one variable. All right? So they give you an example of one right here. Well, they give you an equation that has, originally it has 2 unknowns. Okay, but if it gives you that the length is 15 units, then this equation would only have one unknown variable. Okay, so that's an equation in one variable, meaning there's only one variable that you don't know the value of. Okay, moving on to the next page. Wait, did everyone get that? Sorry, I'll leave that there. Okay, you did. I kind of explained that. All right, so down here, it says an equation that contains two unknown variables or two quantities that vary is called an equation in two variables. That means that the solution is a pair of numbers. Obviously, because you're working with two variables. So there has to be two solutions that make it true. So they give us this like real world situation here. Tyler spends $45 on t-shirts and socks. The t-shirts cost $10, the socks cost $2.50. P represents t-shirts, P represents the number of pairs of socks. So they give us this equation here to represent that situation. Okay, so we don't know what T equals and we don't know what P equals, but we know there's going to be a pair of solutions because we have to know those values. So this is an equation in two variables, and then it kind of goes through and shows you all of the different pairs of solutions that could make this equation true. Y'all see that?
Yep.
All right, it says in the solution, one constraint is that the combined cost of the socks must equal $45. Solutions to this equation are pairs of T and P values that satisfy that constraint. But basically, like we said, it makes it true. Combinations such as these are not solutions because they don't meet the constraint. When we multiply those by 10 and 2.5, they do not add up to equal 45. They result in statements that are false. Okay, so